Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivative. So we have to determine the points where the tangent to the curve is horizontal. Now, if a tangent is horizontal, that means its slope is equal to 0 because tangent is a straight line. So we have to find the points where the slope is equal to 0. So we'll do the analysis for both of these given functions. So let's start with the first function. So the first function is y equals a times x minus 29 times x plus 1. Now we can find the slope of the tangent by finding the derivative of this function. So that's the first step. So we can write, so m, which is the slope of the tangent, is equal to y prime. Now this given function is in the form of a multiplication of two functions. So the first function is x minus 29 and the other one is x plus 1. So we can use product rule to find the derivative of this function. Now the coefficient 2 is a constant, so we'll keep it as it is at the front, and then we'll use product rule to find the derivative of the two expressions in the parentheses. So as per the product rule, so the derivative is the first function times the derivative of the second function plus the derivative of the first function times the second function. So we'll start by writing the first function, so x minus 29 times the derivative of the second function, which will be 1 plus 0, and then plus, now the derivative of the first function, which is 1 minus 0 times x plus 1. Now we have to simplify this expression, so we'll keep the 2 outside. Now since we have to find the point where the tangent to the curve is horizontal, that means the slope of the tangent should be equal to 0. So in this step, we'll just simplify this expression and then set this expression equal to 0 to find the points. So in the first part, we get x minus 29. Now in the second parenthesis, it's 1 plus 0, which is just 1. And multiplication by 1 doesn't change anything. And then in the second part, so 1 minus 0 is just 1, and 1 times x plus 1 will be just x plus 1. Now we can combine like terms in the brackets. So we have to combine x and x, which will be equal to 2x, and then negative 29 plus 1 is negative 28. Now since the tangent is horizontal, so the slope should be equal to 0. So we'll sub in m as 0. So 2 times 2x minus 28. So now we have to solve this equation to find the value of x. So the first step is to divide both sides by 2. So the 2 in the front will get cancelled out. So we get 0 equals 2x minus 28. Now we can add 28 to both sides. So the 28 on the right side will cancel each other out. So we'll get 28 equals 2x. And now we can isolate x by dividing both sides by 2. The 2's on the right side will cancel each other out. And we get x equals 14. So that means there is only one point on the curve where the tangent is horizontal. Now since we have to find the point, so we also have to find the y coordinate of the point, and for that we'll sub in x as 14 in the equation of the curve. So we do y equals 2 and we replace x with 14. So 14 minus 29 times 14 plus 1. Now we have to simplify this expression. So we get 2, and in the first parenthesis, so 14 minus 29 is equal to negative 15. And 14 plus 1 is 15. So now we have to multiply these numbers. So 2 times negative 15 times 15, which is equal to negative 450. So that means the point where the tangent is horizontal to this curve is 14, negative 450. So this should be the final answer for part A. Now we can analyze the curve in part B. Now in part B, we are given the equation of curve, which is a product of two expressions that are the same. So x squared plus 2x plus 1 times x squared plus 2x plus 1. Now since they are being multiplied, we can combine them into a single expression and put a square on it. So we get y equals x squared plus 2x plus 1 and then put a square on. Now we can find the derivative of this expression, and that will be the slope of the tangent to the curve. So we do y, so m equals y prime, which is equal to, now we can use the power rule of derivatives. So we move the exponent 2 to the front and then times x squared plus 2x plus 1 and then exponent 2 minus 1 and times this by the derivative of the expression in the parentheses x squared plus 2x plus 1, which is 2x plus 2 plus 0. So now we can simplify this expression. So m equals 2, then parentheses x squared plus 2x plus 1, and the exponent is just 1. So we should not write 1 as the exponent. And in the second parentheses, we just get 2x plus 2. Now we have to find the points where the tangent is horizontal. That means the slope of the tangent is equal to 0. So we'll sub in m as 0 on the left side of this equation. So we get 2 and then exponent x square, parentheses x squared plus 2x plus 1. Now from the second parentheses, we can factor out a 2. So we get 2 and then x plus 1. So we get 0 equals, so 2 times 2 is 4. Now the expression in the first parentheses is a simple trinomial. So we can factor this expression. So if we factor this expression, we get x plus 1 times x plus 1 and then times the third x plus 1, which is the last parentheses. So now we can combine these three parentheses into x plus 1 cube. Now we have to solve this equation to find the x value at which the tangent is horizontal. So the first step is to divide both sides by 4. So the 4's on the right side will cancel each other out. So we get 0 equals x plus 1 cube. Now we can apply cube root to both sides. So the cube and the cube root on the right side cancel each other out, and we know that the cube root of 0 is equal to 0. So we get 0 equals x plus 1. So now we can solve for x by subtracting 1 from both sides. So the ones on the right side cancel each other out. So we get x equals negative 1. So this is the x value at which the tangent is horizontal to this given function. Now we have to find the y value for the point. So we'll sub in x as negative 1 in this expression. So we get negative 1 squared plus 2 times negative 1 plus 1 times. So we do the same in the second parentheses. So negative 1 squared plus 2 times negative 1 plus 1. So now we get y equals, so negative 1 square is just 1, and then 2 times negative 1 is negative 2 plus 1. And we get the same expression in the second parentheses, so 1 minus 2 plus 1. Now 1 minus 2 plus 1 is equal to 0. So we get 0 times 0, so y is equal to 0. So that means there is only one point at which the tangent is horizontal to the second curve, and that point is negative 1 comma 0. So this should be the final answer for the second curve. So these are the steps you have to keep in mind to solve this type of problem. So you have to understand and memorize that when the tangent is horizontal, that means its slope is equal to 0. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.